Hi everyone, my name is Shreyan Shandelia and I'll be teaching you Introduction to IoT and Development Boards on behalf of RoboISM, which is the Robotics and Artificial Intelligence Club of IIT ISM Dhanbad. IoT or Internet of Things refers to the collective network of connected devices and the technology that facilitates communication between devices and the cloud, as well as between the devices themselves. Thanks to the advent of inexpensive computer chips and high bandwidth telecommunication, we now have billions of devices connected to the internet. This means everyday devices like toothbrushes, vacuums, cars, and machines can use sensors to collect data and respond intelligently to users. In a nutshell, when we integrate everyday things with internet, it is called Internet of Things. Now let us talk about the evolution of IoT. The Internet of Things integrates everyday things with the internet, as we read earlier. Computer engineers have been adding sensors and processors to everyday objects since the 90s. However, progress was initially slow because the chips were big and bulky. Low power computer chips called RFID tags were first used to track expensive equipment. As computing devices shrank in size, these chips also became smaller, faster, and smarter over time. Now we'll talk about the working of IoT. A typical IoT system works through the real time collection and exchange of data. An IoT system has three components: smart devices, IoT application, and a graphical user interface. We'll understand all these components one by one. Smart devices. This is a device like a television, security camera, or exercise equipment that has been given computing capabilities. It collects data from its environment, user inputs, or usage pattern and communicates data over the internet to and from its IoT application. IoT application. An IoT application is a collection of services and software that integrates data received from various IoT devices. It uses machine learning or artificial intelligence technology, that is, it uses the algorithms in these technologies to analyze this data and make informed decisions. These decisions are communicated back to the IoT device, and the IoT device then responds intelligently to inputs. And then finally, we have a graphical user interface that manages an IoT device or a fleet of devices. Common examples include a mobile application or website that can be used to register and control smart devices. Now we'll talk about some examples of IoT devices. The first example is that of connected cars. There are many ways vehicles such as cars can be connected to the internet. It can be through smart dashcams, infotainment systems, or even the vehicle's connected gateway. They collect data from the accelerator, brakes, speedometer, odometer, wheels, and fuel tanks to monitor both driver performance and vehicle health. Connected cars have a range of uses. Monitoring rental car fleets to increase fuel efficiency and reduce costs. It can be used to help parents track the driving behavior of their children. It can be used to notify friends and family automatically in case of a car crash, or it can be used to predict and prevent vehicle maintenance needs. The second example is that of connected homes. Smart home devices are mainly focused on improving the efficiency and safety of the house as well as improving home networking. Devices like smart outlets monitor electricity usage, and smart thermostats provide better temperature control. Hydroponic systems, which is quite an advanced topic, uses IoT sensors to manage the garden, while IoT smoke detectors can detect tobacco smoke. Home security systems like door locks, security cameras, and water leak detectors can detect and prevent threats and send alerts to homeowners. Connected devices for the home can be used for automatically turning off devices not being used, rental property management and maintenance, finding misplaced items like keys or wallets, or for automating daily tasks like vacuuming, making coffee, etc. Now we'll move to the second part, which is development boards, which is nothing but a PCB, that is a printed circuit board with a microprocessor or a microcontroller mounted in it with many components. Development boards are made for learning purposes mostly and can also be used in industrial applications as well. They are also used for prototyping before releasing the main product. They have been also used for testing and debugging purposes. The most common development board which we'll encounter is an Arduino Uno. An Arduino Uno is based on an Atmega 328P microcontroller. It includes 6 analog pins, 14 digital pins, a USB connector, a power jack, and an in-circuit serial programming header. It is programmed based on an integrated development environment which can run on both online as well as on offline platforms. The various components of an Arduino Uno are a power LED indicator which indicates whether the Arduino Uno is on or off. We have 14 digital pins numbered from D0 to D13. They have the value high or low, with high corresponding to 1 or low corresponding to 0. We also have a reset button which is used to reset the connection. We have a USB which allows the board to connect to the computer. It is essential for the programming of the Arduino Uno board. We have a crystal oscillator that has a frequency of 16 megahertz, which makes the Arduino Uno a powerful board. We have a voltage regulator which converts the input voltage to 5 volt. We have ground pins which act as zero voltage. We have input voltages, and then we have analog pins. There are a total of 6 analog pins numbered from A0 to A5, whose function is to read the analog sensor used in the connection. It can also act as a general purpose input output pin. The technical specifications of an Arduino Uno are that there are 20 input output pins present on the Arduino Uno board. Of these 20 input output pins, there are 6 pulse width modulated pins that are used to control the output power, 6 analog pins, and the remaining 8 are digital input output pins. The input voltage of the Uno board varies from 7 volt to 20 volts. Now, to get started with Arduino, you'll have to install the Arduino IDE, which is available on the official website of Arduino, which is arduino.cc. To read more about Arduino, you can visit its official documentation, which is docs.arduino.cc. That is all from my side. Thank you.